Hi, everyone. Thank you for coming. Last talk of the day, almost.
Almost.
So I'm Matteo. He's Luca. And we are here today to talk about a development journey on deploying node.js at scale. First of all, let us do a quick disclaimer. So all of what we talk today, apart from the stuff that is related to node.js, is completely fictional. And like this developer journey doesn't want to offend anybody or anything. It's not based on any real thing that happened. It's just a combination of all the experience that we had in our own life.
And a tiny little bit of our craziness.
Exactly. So first of all, let's start. Let's meet Bob.
Hey guys, I'm Bob. I spent my life building Lava application. And I built this application, and I'm a big fan of SQL Lobster. Great library.
So Bob reads a nice article.
I got inspired by Kian. I read this article that Node.js can fit every enterprise and at scale application. And I said, yeah, it's the time for me to get Node a chance. You know, after a life building Lava application, I said it's time to make a small change.
Lava,
yeah.
Lava applications.
The extension is important.
Exactly.
And so what I decided to do was basically to, after reading this beautiful article, to just go on the internet and start to take some libraries. And
so,
I said,
yeah, but go ahead.
I said, well, I was inspired by the speed, and it looks so enterprise. And I said, I need to give it a chance, definitely. So I picked my favorite libraries. Sorry for saying that. I went for Express, great library. Amazon, Angular, Node. And I said, because I'm using Mongo, I'm going to use Mongoose, great library. It remembers me of the time of Hibernate, when I was super, super pumped up. And so I said, I'm going to choose the mean stack.
So Bob starts coding it. It uses powerful generators, and it can create an application very quickly. And this application has the form of a nice monolith. We have had a great lot of talk today about microservices, so you can think what you want. So how you deploy your monolith? So in order to deploy your monolith, you go to Stack Overflow. That's the first point when you don't know anything, right, Bob?
First step, Stack Overflow all the way.
So you SSH into the box, and I don't know, set up some servers, Git Clone. You use a nice library called Forever to run your node processes forever.
Or PM2 if you want to be a little bit more enterprise-ish.
He's a nice .lava developer, and it writes code with 100% code coverage. The product had huge success.
Yoo-hoo!
And however, the performance falls down after it gets some the first users. So what happened? In fact, it's a really good thing. Wow, Node.js, come on. So you know, everybody says Node is fast, but the performance falls down completely. We used Node. We decided to use Node because Node was this fast and super awesome framework. What happened? Well, I coded my. He is a .lava application.
Yeah, don't become myself. 20 years
and
of
he
experience.
coded his application as using a relational schema. Remember, he used MongoDB. So how many of you have used MongoDB in your life? Okay.
Sorry.
How many of you used, you were like, oh, how can I do a join using MongoDB? One guy asked himself, how can I do a join on MongoDB? So in all the applications that was using the main stack, and this is I come from myself, what I always seen was this type of relationship. So there was one collection for a class, for a type of element, and one other collection that needed, with the data, that needed a join. So there is a nice, the Mongoose library has a very nice function there called populate. So populate, this is what populate does. So populate you start with this nice sentence. So it's truncated. I will read it for you. There are no joins in MongoDB, but sometimes we still want reference to documents in other collections. This is where population comes in. So basically, populate in Mongoose allows you to build your application writing a join engine inside your application code. So there is a reason why in SQL database we do joins inside the database. Performance, and really important performance reason to do so. So this is the reason why the first iteration of Bob application didn't work. By the way, this happened to me probably 10 times. So this is how populate works. So basically, you can use find or find1 or find in the MongoDB API, on Mongoose API, and then you can call populate. The problem is, like, if you use find1, it will just use 2 queries to read your data, which is still kind of OK. The moment you try to call it with find, so you find a collection, you ask, please return me all the elements here. And for all the elements, it's going to look up the stuff on the other collection. The number of queries grows exponentially up till, to some point, the MongoDB database. It says, well, you haven't probably did a good job designing your schema. So turned out that Bob learns that NoSQL is hard, and it's not a magic bullet. And in fact, if you want a relational database, code it using a relational database. Don't use a NoSQL database if you don't want to deduplicate, for example. And deduplication means that you want to embed your email type inside your JSON data. I highly recommend Postgres, and in fact, this is what Bob
is going to do.
Bob is going to do it, ditch MongoDB for Postgres, because, even the Mongoose library is not really good. Let's change the database, because that's...
I thought it was great, actually. I loved it.
So product as a huge success again. But then...
No! It crashes.
So...
Even on Amazon.
Yes. So you have this nice scenario, Bob. Your servers, on a Saturday morning at 7:50, your phone rings. All the servers are blocked. You can't even SSH into them anymore. What do?
Whoa, that's actually funny. I think I'm not going to pick up my phone, but if it's a sunny day here in Holland, but it's actually better than 3 a.m. in the night when it happened previously.
Well, anyway, you do the Windows 95 way. You just restart, and they come back online. Still, you need to fix the bug. And again, Node.js is such speed and whatever. We pick technology in this way. So what happened was that Node.js is really good at using the resources on your system. And in order to make it, and a slight bug in Node.js, in your application code, can even cause some problems at operating system level. For example, the file descriptors. So every incoming HTTP request that is in your app is a file descriptor. And if you, from your app, you go to a database, or you call another software as a service, some API, different API, it's another file descriptor. So you have 2 file descriptors for each request. What happens is, if there is an error, and if your error ending is not perfect, what will happen is that one of those 2 file descriptors that is not properly closed and collected. The problem is the number of file descriptor is fixed. So if you're not closing your file descriptors, you're basically filling up your file descriptor table, and you can't even SSH into the box anymore because there are no more file descriptors. How do you fix it? Well, usually this is the problem for a.pipeb. How many of you have used the pipe thing in Node? OK, yeah, some of you. OK, hopefully. If you're using pipe, go and replace everything with pump, which protects you for this very specific problem. So if you have 2 streams of data, you need, even in a case of error, it will call pipe for you. and it will close all the stuff.
And socket.
So,
back online. Yes, I can go to kitesurf. Only sunny day in Holland.
Now, it's business time. And the business says, oh, Bob, you did such a great job all alone. Let me give you 4 more people and a lot of money to develop your new, to make this product better and serve more customers. Yay! So, again, Node.js will take that far.
For free.
This was predictable, OK? Something didn't work out. Well, the major problem is the bigger your application becomes, and the more people you add to your system, you write your code using one of those nice MVC patterns. And this was made popular by Ruby on Rails and others some years ago. The problem with this approach is that what you are building is a monolith, OK? And in this kind of architecture, every time you want to add a new feature, you need to touch every part of it from a macroscopic point of view. There is no conceptual way of separating the different features, separating the bounded context that some previous talks said, which means this does not scale on the team size. So if your team grows, basically people start stepping on their own feet like this. And also it means that for the different features, we need to scale all our servers to handle the most complex and high CPU-bound tasks.
And you still have one database.
And you still have one database, MongoDB. No, Postgres now.
Postgres.
So, and also, how many of you were in this scenario? Please, guys, don't push, don't commit for today. I'm doing a huge refactoring of all my code base. Yes, OK, yeah. Because, you know, when you have this kind of monolithic problem, you have a lot of problems in handling the change in your app. So there is a better way to do it, and Bob takes it to himself. Instead of using an MVC pattern, I just refactor my stuff based on the different functions of my applications. So I code them in different little modules that just do their own functionality. They do it however they want. But this means that the different developers can work on different areas of the code independently.
Hey, but it's a very great, well-organized monolith now.
Exactly, at least. At least it's a good monolith. It's a big block of stone. OK. So this works, kind of. Still, you have problems in production because you have all equivalent nodes and machines.
I'm kind of happy. Except that I'm using Happy, but that
You're
doesn't
using
matter.
Happy. You moved to Express. From Express to Happy, we changed web framework. We changed database. We changed a lot of things. He's using Happy. You pass it from look. What is the Express face? What is the Happy face? OK, he doesn't like anything. None of them. Of course, the business wants more. OK, the business always wants more. Have you ever got a case where the business wanted less? So it's more feature in less time this time. So I'm giving you 20 developers, not you move from 1, Bob, to 5, then 20.
Hey, but life was beautiful. I had a lot of friends during that time.
Yes. You have 10,000 unit tests. You want to write 10,000 unit tests and serve even more customers.
I don't know how to make the desperate face.
What happened was that all these new people mean a lot of new servers and infrastructure. And, well, more infrastructure means also like deploying all these new servers and doing all this new stuff. We are still deploying using SSH and configuring.
But you can scale on DevOps now. You can have many more DevOps. Before you had only one, now you have a plenty of them.
Also, the monolith doesn't really provide a lot of fault tolerance and resiliency in our system. So maybe Bob's initial decision to go with the cargo cult and adopt a pre-made stack was not really the best possible solution.
Hey, but Walmart did it. Stack Overflow told me to do it. What do I have to do?
Exactly.
I mean...
But Walmart didn't use the min stack, man.
Oops.
Anyway, if you're building a complex application, it's, you need to think of what you are going to use. You can't just go with the trends. You need to make a decision for yourself. So I think Node is good, but you might not think Node is good, first of all, and definitely put some thinking into it.
Oh, my lava.
So, yes, OK. Like, let's throw everything away and rewrite it. That's what happened in this case. Like, and everything falls apart, and somebody says, let's just rewrite it.
But isn't it refactoring, actually, this one? Isn't it refactoring, actually?
Yeah, because, you know, instead of throwing everything away and using .lava42 because it's a new version, we go into hipsters and start using microservices. So microservices. Again, we chose microservice for very important reasons. Yeah, OK, you can make a picture. So this is a nice one. And after...
By the way, it's not me on the picture, right? If anybody was wondering.
So again, we have microservices are extremely popular right now, and one of the most common technologies out there, and everybody's talking about adopting microservices. We are not going into containers, OK, in this talk, so don't worry.
We're also in a warehouse, so...
Exactly. So right now, we move to a nice microservices architecture.
Look how beautiful, by the way. Look how beautiful. The colors, really, they make the architecture much more
I made
solid.
all of this with Omni Graphle, OK? It's really cool. That's part of my job as an architect, OK? I write diagrams. So what happened with a microservice is basically we scale up our modules so that right now we have different node processes running on different boxes. Each of them specialized for their own handling, their own features. We have a bunch of main servers that basically dispatch all of this. All the communication happen in all the possible ways. We use queues, pub subsystems, whatever.
ESB.
ESB. How many of you have used an ESB in your life? I'm sorry for you.
And Oracle Service Bus, how many of you? You just waste, I think, 200K in a license.
Yeah, of course. I didn't pay for it, but yes. Anyway, so we use a tool called Fuge. Fuge is a nice automation tool for developing microservices that we have built. I'm not showing you the full demo, so it's on the website. Fuge.io is kind of nice. And it allows you to spin up a complex topology of microservices locally on your system. We start doing a queue. The queue interaction doesn't really work, right, Bob? What do you think about queues, Bob?
I don't know. I remember at the time of Oracle it was working, but we also took 15 minutes to dispatch a request. So.
OK, so it's not really good for real time and so on. So yeah, maybe not really good. Now we go for the answer to life, the universe and everything, which we all know being 42. But instead, we say the service discover. So the major problem for any microservices, every microservices deployment is how the microservices talk to each other. We need to know where they are and what are their capabilities. And now, it's turn.
So, service discovery is a bitch, and we all know. More you scale microservices, more they're going to deduplicate themselves inside of the network topology. So, some time ago, actually, HashiCorp built this beautiful tool, Console. And they sold it to everybody as the solution to service discovery. But I don't know if you noticed. I mean,
it doesn't show. Come on, it's terrible.
That was the joke. But now I can make you laugh anyhow. So they actually said we can solve the problem of service discovery. Just give you an agent that you install on your machine, and you need to deploy a cluster of Console to make service discovery. So I'm going to add an extra component. And actually, this one is the DigitalOcean Quick Start Guide. And it's too bad that you cannot see it, but on the right side of the slide that you will see online, there's actually a minified version that I think is long 30 pages, so it's never ending. So definitely it's not going to work, you know? We want to be fast and cost efficient.
Like, you see, you can keep scrolling and scrolling and scrolling. It's that thick. You see that bar, that blue bar? That was the end of the page starting from the top of the slide.
And it's minified.
Really, it's really long.
So, well, I didn't really feel to read the quick start guide because, time is limited, life is too short for consult. And the other solution was actually to run on HDD. Who actually is acquainted with HDD and CoreOS? Okay, well, you have only one thing. Actually, you're not paying a lot because HDD is included in CoreOS. The only problem that for all your life you need to run on CoreOS, which basically is a kind of hell. I can never actually get it running really well on my Mac, maybe because it's an old one. But then actually somebody at Cornell University wrote this white paper. How many of you are acquainted and they know what Swim is? Okay, so just to be very, very quick, Swim is basically, how many of you actually they are acquainted with peer-to-peer network? Okay, how many of you are downloading illegal movies from BitTorrent?
Okay,
Great.
Wait a second.
Great.
Let's do it again.
By the way, it's recorded, the talk. We're going to send it to the police, but don't worry. Well, imagine like a big peer-to-peer for microservices, right?
And enterprise solutions.
Everything is enterprise, guys. We're not building stuff for startup here. So what Swim means is just a scalable, weekly consistent, infection-style membership protocol. I mean, it's clear, right? So
this means that I told to him, and then I go talk to you.
But Swim is a little bit faster, by the way.
Yes.
And the important part is that we are actually, with microservices, we are entering the world of distributed system, right? And distributed system, actually, they must be weekly consistent. Imagine banks, they are not strongly consistent anyhow. So how many of you know, actually, that every night, the bank reconciles your balance? So it means that if you now go to check your balance, what you see is actually a kind of guesstimate that the bank is doing upon all your transactions. And during the night, it's going to be reconciled. There are banks that they reconcile every 72 hours. So there is a solution for that. Just keep your balance to 0, and you're sure that actually having no money, you are strongly consistent. Else you are actually weekly consistent.
By the way, some of the processing of a credit cards company is done via FTP.
Yeah.
So just if you didn't know.
So the big advantage is that this protocol, Swim, was born for a distributed system. And actually, the nicest thing that is doing is actually failure detection. In a cluster of machines, the biggest problem is always failure detection. There are different ways of doing it, that is basically doing R-bitting or basically having an agent that ping all the different machines. But in a gossip world, all the nodes of the cluster, they talk with each other and basically keep the state consistent and rotating across the entire cluster. And something that I really like about Swim is the fact that you can finally have deterministic distribution of the workload. Because the topology and the state of the cluster is basically weekly consistent, but very fast updated. I mean, don't try with consult, please. Well,
everybody is talking about Swim. So if everybody is talking about Swim, why should we not use it?
It should be cool, I mean. But let's just get with feet on the ground. There are two basically companies that are using Swim, and they have two kind of big implementation. So if you're into Go, and you're into monolithic application, you can go for HashiCorp, which is great. So Surf is their basically gossip membership library system. Well, I even don't know how to define it. And it's actually part of Consult. So basically, they try to solve service discovery using gossip through Consult, that is a distributed key value storage. The other solution is that, and is what me and Matteo like the most, I think, is Swim.js from this guy. Just check his library, it's pretty interesting. I think Matteo is also contributing to the library.
Yeah, I sent a couple of PRs, fixed a couple of bugs.
Maybe the README should be the next thing to fix.
Yeah, but don't worry about the READMEs. Like, who is using libraries that have nice READMEs, right? There is the source code. The true developer just go to Stack Overflow and ask questions.
But don't worry, we're arriving to the moment where we're going to unveil one of the secrets of Fatima. How many of you know who Fatima is? Okay, so religious is based upon this secret, and we are going to unveil the fourth one today. Well, we're still working on it, but we are very close. But just keep your eyes open and try a couple of slides, and you will see something extremely famous. How many of you are using Uber? Anybody of you working for Uber? Great. It's the right place where to be right now. Not Uber, I mean. So imagine I have this scalability problem. So I'm running this huge cluster. I have millions of requests per second to handle. So a new node in the cluster is added. Don't ask me how it's added, because yesterday I was talking about Swim in London, and some people, they asked me, okay, but is Swim fixing the problem of recognizing the workload across the cluster? I said, no, that's something different, right? So a new cluster node is added, and the main difficulty of service discovery is how to update the service topology, so the cluster topology. And it has also to be rebalanced.
To spread the load correctly.
Else it's not a cluster. So there's a lot of magic involved, right? And we all love magic. Well, there's not really a lot of magic. It's a simple algorithm. Well, simple, not really. How many of you are acquainted with consistent hash strings? How many of you are using DynamoDB? Okay.
React?
Great, great. So you're using a consistent hash string every day, the 4 people that are using it. For the other, actually, the consistent hash string is nothing more than a system that solves a problem. And the problem is, how can I find a server over an unstable network? Because distributed computing is based upon the fact that it's unstable by definition and is inconsistent. So what it's doing, basically, the consistent hash string is basically defining the location of the server across the network. Now I'm gonna show you a little bit an image. This one is the image that explains everything.
So don't try to understand it. I didn't. You need to put down and do the math yourself for like half an hour. After that, it's all clear.
Imagine like a spinning wheel,
yes,
where I put a cluster, and it's like the fortune wheel. There are some slices, and this slice is actually called shard. So how many of you are using MongoDB? Great. Well, you're using shards, basically. But shards is just a way of partitioning, right? So the big advantage of using a consistent hash string is the fact that you basically avoid and skip the problem of hotspot. So basically, you distribute again. Partitioning. And I actually think the nicest thing is that it's a continuous replication of the state. So while in a microservice environment, every service is stateless, and the state of the machine is left to the machine himself, now the consistent hash string, the state is distributed across all the clusters. So every node knows about the state of all the other nodes. So you can play trick like reply forward across the network. So if I pick up the request and I cannot satisfy that request, I can forward it to the next node that can answer it. Does it make sense till now? Keep your eyes open, because we are unveiling the secret. Well, Matteo built a library for that, for basically having a consistent hash string across the network. It's called appring.
This was born for a very specific pain. I tried to use some libraries, and I couldn't really. So I wrote it myself. This is still an ongoing project. So I set the thing up. It's working. It's definitely not production ready. But if you are interested in playing with these technologies and in helping out, please reach out. It's
very simple.
Nice, and it's simple to use and set up.
So now we unveil the secret. Bob had always had a dream, was to work for Uber. And that would have been his life. Apart having black t-shirt all the time. So Uber actually was the first company that publicly announced their solution for highly available and scalable microservices. So Uber is running, if I'm not remembering wrong, what Dan told me, something like 20 million transactions per second across their entire cluster. And they built a library called ringpop. And that's where Matteo started his journey in building appring, because ringpop is a scalable, fault-tolerant, application-level sharding library. Did you get what it means? It means basically that it allows, on an application level, so we're speaking about layer 7, to distribute the load across a cluster. Now,
10 minuti.
This one is what sharding means. Imagine. So I'm running a user service, and I shard, so I partition by user ID. And there are different nodes in the cluster. Imagine that I have 3 segments based on user ID, and they're basically distributed to the 3 nodes of my cluster. And application level means that my application, so no other third component, is responsible of determine which cluster node will handle that particular request.
And by the way, a very important piece here is that if you remember that Node.js is single-threaded, and you just run one single thing at the same time, with this particular scenario, it will mean that all the stuff that's coming from that user is going to be executed on that instance, which also means that you can actually do some magic tricks, for example, treating state in memory or WebSockets or other resources that cannot be persisted or scaled normally.
Well, remember, it has to be resilient. That's the most important thing, and fault tolerant. So, and that's the fourth secret of Fatima, is there. So, Uber wrote 3 libraries, and hyperbond is the second one, which is basically gonna give a meaning to the consistent hash string. And hyperbond is a service discovery layer built on top of ringpop. So imagine my HTTP request comes in, and hyperbond makes service discovery based on a consistent hash string. So basically, all the state and all the topology of the cluster is in memory, and hyperbond just makes routing. So if you read the documentation of hyperbond, this one is the only thing that is understandable. I think as of today, me and Matteo are still in doubt if we really understood how hyperbond works. But the only thing that we know is that it's just a service discovery library based on a consistent hash string.
There is no documentation.
Well, I mean, if you are Uber and you build it, then for you it makes sense. But the nicest thing, I think, is circuit breaking, and especially distribute tracing. The 2 most important things in distributed system. First of all, imagine that is a ring, so that the information are going to spin in this ring and are going to reply and forward until they're not resolved. So if you don't have circuit breaking in your service discovery, you're going to basically fail completely and go in an infinite loop. So you're going to kill your cluster, basically. And if you're running on Amazon, it's going to cost you a gazillion amount of money, especially if you are so stupid to use the ELB and auto-scaling groups. But the most important thing is distribute tracing. Well, let me say that basically what Uber also decided was to kill HTTP. The request comes in from an HTTP or thrift request. It enters the consistent hash string. It gets dispatched to the correct cluster node. And by the way, they're using this library for their real-time dispatch system. So when you order an Uber, you're using ringpop. And to glue all the stuff together, they needed to kill HTTP and to build a protocol that was basically changing a little bit the methodology in which basically the servers they were reached. And T-channel, for example, the most important thing, it puts RPC and tracing as a first-class resident of the protocol himself. It's just a TCP interpretation. So if you go and read the specs, actually, T-channel is actually pretty well documented.
Yes, T-channel is really well documented. It's a really nice thing. It doesn't really work on Node 4, so no. I don't know. I'm not so fond of it, but it's very well documented.
If you're running distributed system, you just need to do one thing. You need to take a screenshot of this library. It was written by Twitter, and it solves the problem of request tracking. So I don't know how many times we got fucked by logs.
I don't know if you can say fucked.
by basically, and check Zipkin. It's just insane. And if you are reading the documentation of T-channel, you see that Zipkin is a first-class resident inside of the protocol. But why RPC? And it's very simple, because at the end, what we're going to do, we're going to offload HTTP at the edge and reach functions that are running on a cluster. So we are basically just make a remote procedure call on functions that are running on a node instance somewhere in the network. We don't care where they are. We just say, this HTTP request has this handler, and this handler, thanks to the consistent hash string, we know where it's located. Well, how many of you know what this symbol is? Is AWS Lambda, and is the first attempt to basically go to this kind of direction of having a kind of distributed function. they kill operation complexity of DevOps, but unfortunately at the cost of killing the development workflow. So using an in-app solution like ringpop actually take you back to have a complete control of your development stack. Well, Lambda is going to kill it. How many of you are running Lambda, by the way? I'm sorry for your life. You know, we spoke about hipster, and serverless is just the new hipster term, like microservices.
Of course, like you expected this at this point, right? Okay.
And
like a lot of servers and serverless, whatever.
We heard so many talk about functional and functional reactive programming, so hipster. But I do believe, and I think I speak also for Matteo, that distributed functions are the future. So imagine a world where basically developers, they only write function, and they can abstract completely the complexity of operations and networking. My dream is to kill DevOps, but I think it's going to take a while. So my suggestion is don't be too late. Just try to learn about what distributed computing at scale based on function is. And, well, just like we said in the beginning, you can reach me if you're interested to know something more about hyperbond. I don't work for Uber, by the way. But I'm pretty interested in what they do, the guys. And Matteo...
I do a lot of open source, as you can see.
So. Are you working for Uber, by the way?
No, I don't work for Uber.
Okay.
So let me see. I work for Nearfirm. I do. I maintain Level Up community. If you haven't ever used Level Up, you can do it. I am a collaborator in Node Core. I help out in a microservices framework called Seneca, and I am the lead maintainer of another library called MQTT.
Oh, I forgot even to say. I spend my time now contributing also to Node Core. I almost forgot about it. Yeah, I work on the postmortem. So if anybody has questions about MDB or low-level debugging, bring me. I love it.
So, yep.
And
yeah, well, this company here, if you have any issues or whatever. Yeah,
and it's sponsoring Upring, actually.
Yeah, well, they are sponsoring the Upring stuff. So please, if you want anything, if you need some help on Node, reach out. But
I'll let you close this talk.
Yeah.
I give you the honor.
Yeah. So, well, first thing, think before about choosing a technology, or a framework, or an architecture, or a database, or the way
or a company where to work.
Yes, that's a broader discussion of another talk. But yes, so think. It's highly important to do the right choices. And don't think too much, experiment. It's not a problem if you make the wrong decisions. The problem is realizing that we learned something, and we took a wrong path, and now we are doing better. Don't follow what everybody else is doing just because they are doing it. Think why. Node works at scale. Yes, -1, I'm going plus. Don't worry, I'm going to be late. So Node works at scale.
We are Italian, you know, we're always some kind of delay.
Yeah, a little bit late. So
we are famous for that.
We are working a lot of different companies and industries, and Node works. And if you have any questions, we can talk about it with a beer or something else later on, or a coffee after. But we can make you a lot of examples of that, of how well it works in production. The last thing is that in all of this talk is clear, and one of the messages is that you can implement any architecture you want in Node. You want to do a monolith, you can do a monolith. You want to do microservices, you can do a microservices. You can write all your application in one single JavaScript file. Yes, you can do that. Okay? So experiment and contribute back to the community, use open source libraries, send pull requests. And I don't think do I have some time for questions? Can I be over time, really? Two questions. Two questions. So we have 2 question time.
But
so
by the way,
don't
ask us how it works hyperbond, because we still don't know it.
Who wants this in his head? Because he says I can't throw it in the head of anybody.
Don't be shy.
Don't be shy. Nothing? No question? No questions? No questions?
It works.
It works. So no question. Thank you, guys. And we want to make a question.
No.
No. OK. Thank you, guys.